Okay, gang, we are staring down the barrel of chapter 13. Last chapter, we did analysis of variance, ANOVA, as a independent measures design. So typically 3 separate samples coming from 3 separate populations and single factor. Remember, the term factor was just the term we've been using now for independent variable or treatment. And remember, we can tell what the factor is by asking what the difference is between the groups. Treatment condition 1, treatment condition 2, treatment condition 3. What's the difference? Oh, well, whatever the difference is between them, that's the factor. So this week, this chapter, we are doing the counterpart to that. It's still an ANOVA. It's still analysis of variance. Pretty much everything we've already learned how to do, we're going to do again in this chapter. Almost every calculation we've already made will end up in this chapter as well. So it's the last chapter plus a little bit more. But now we are going with repeated measures design, meaning that now it is the same sample moving through each of the treatment conditions. So how does my sample do on some problem-solving task in a cold room? How does my sample do the same people now in a room that's warm? Now, how do the same people, the sample, repeated measures, how do they do in a room that's hot temperature, right? 3 different treatment conditions. The single factor is temperature. That's the difference across the conditions. Low temperature, medium temperature, high temperature. But it's the same sample moving through all of those conditions. So in the last one, I was doing a medication example a lot, 0 milligrams, 10 milligrams, 20 milligrams. Well, in this case, we could still do that, but the sample, we would measure them with no medication, then put them on 10 milligrams for a while and measure them, and then put those same people, change their medication up into 20 milligrams and measure what that does. So just like repeated measures meant in a t-test, it's what it means here. The same sample, the same group of folks measured repeatedly. In this case, typically measured 3 or more times. So we're going to start with a broad overview like we usually do. So let's look at what we've already done. Starting in the last chapter, we took the idea of our total variance, the differences in the scores across the entire experiment, and then we broke that out into 2 categories. We broke that out, I'm going to draw it just a little bit different with the arrows here, as a between treatments variance and a within treatments variance. This is what we did last chapter. It's also what we do this chapter. So remember, variance means looking at differences. So we take the differences across all our scores for the entire experiment across all the different treatment conditions, and we say what are the differences between the treatment conditions? Treatment condition 1 versus 2 versus 3, cold room versus warm room versus hot room, right? And then we look at the difference of the scores within a treatment condition. How do the scores vary just within the cold room? And then how do the scores just vary within the warm room or just within the hot room, right? This is still what we're doing this week. So all of these calculations associated with this are the same. So let's remind ourselves that when we're measuring our between treatments variance, part of what we're measuring is the treatment effect. And part of what we're measuring is just plain old error. Sampling error, measurement error, all kinds of things that account for the differences between the treatment conditions, between the treatment groups. That is still true. Our within treatment variance, remember, was just all error. So this is what we often call stage 1. In a repeated measures ANOVA, we think of this as a 2-stage process. So the first stage is identical to the independent measures ANOVA. The first stage is doing what we already know how to do. Break out, analyze our variance into between treatments variance and to within treatments variance. But let's think about some of this error. Well, it'll be on both sides, but some of this error. In an independent measure study, we said that some of the error between treatment conditions was due to individual differences. That there was a different sample in each condition. The people in the cold room were different humans than the people in the warm room or the hot room. So we would have found that individual differences would have made some of this error between treatments. But in a repeated measures ANOVA, there are no individual differences in the between treatments variance. And remember, this is our numerator for our F ratio, our F statistic. You can't have individual differences here. Why? Because it's the same people all 3 times. These 10 people in the cold room are the same humans as the 10 people in the warm room, same humans as the 10 people in the hot room. So we're comparing people to themselves. So this error associated with between treatments variance naturally is individual differences free. It just can't exist there because we're comparing people to themselves, not to different strangers. So this error is naturally free of individual differences. So just regular sampling error, measurement error, other sources of error, there's still error. But individual differences can't live here. But over here on the within treatment side, we can still have individual differences, even with a repeated measure study. Because remember, now we're looking at the differences of scores within a single treatment condition. So I've said 10 people in the cold room. Well, those are 10 different people. Why did participant number 1 score different than number 2, different than number 3? It's not because of the temperature. They're all in the same temperature room. They're all in the cold room, whatever temperature that is. So the differences would include individual differences. So this error cannot contain individual differences over here on the between treatment side. Again, because we're comparing people to themselves across the groups. But this error so again, obviously I'm abbreviating here. This error within treatments does contain individual differences. If you think back to chapter 11, when we were doing our repeated measures t-tests, we had done chapter 10, our independent measures t-test, then we did chapter 11 for our repeated measures t-test. And one of the things we did is we went to a page in the book where it looked at the differences in those 2 designs. And one of the things we did as a class was we calculated how much error we would save by doing the repeated measures, by getting rid of the individual differences. Well, that's what we're going to end up doing formally as part of this test. So again, what I've said already today is that this is called stage 1, where we are simply going to take the total variance and divide it across the between treatments variance and within treatments variance. But now we're going to take it a step further into a stage 2. The point of the second stage is to remove these individual differences out of our denominator. Remember, we've been doing within treatments variance as our denominator up to this point. But what we're going to do is take all this error, calculate the individual differences, and literally subtract it out of the error. We can measure it, account for it, and delete it from influencing our data. So in the second stage, the point is to remove the individual differences from the denominator. It's already naturally individual difference free in the numerator. It's the denominator where we have to take it out. So we're going to take all this variance related to error, just again, we call it the error term, and we're going to subdivide this into 2 piles. So we're going to take this big pile of error right here, and we're going to calculate what's called between subjects variance. Remember with ANOVAs, we've been getting new terms for old ideas. The word factor is a new term for an old idea, treatment, or independent variable, right? MS, mean of squares, was a new way of saying variance. We'll still be using that term. When you see the term between subjects variance, that's just what they call individual differences in an ANOVA. So between subjects is a new way of saying individual differences. Variance is difference. The differences between individual people, between individual subjects. So between subjects variance is individual differences. So we're going to take all the error, calculate the between subjects variance, the individual differences, and subtract it out. And then what we're left with is the error free of individual differences. Sometimes you can see I wrote it's called residual error. It's the leftover error after we take this individual differences stuff out. So what we end up with is our numerator of our F ratio stays the same, absolutely unchanged. Same calculations, all the same. But our denominator, instead of using the within treatments variance as our error, again, we're going to calculate the individual differences between subjects, subtract it out, and simply use what's left as our denominator. Numerator, denominator. So you've noticed in the tables, both for the critical F and to get your Q for running a post hoc test, it's kind of coy, I guess, when it says report the degrees of freedom for the denominator. Why not just say it? Because the denominator changes with the chapter. The numerator remains the same. They could have always said that, but the denominator changes. So in the last chapter, within treatments variance was the denominator. In this chapter, just straight up error or residual error that is free of individual differences is our denominator. Numerator, denominator. So from here we will do our standard routine. It should go fairly easily because most of it, all the stage 1 stuff is the same. It's just stage 2. All of this is the stage 2 part right here. We'll just have to learn how to do that part. Otherwise, it's the same as what we've already been doing. So we'll start talking through our steps in the very next video class.